Hello guys, this is Brandon and I'll be doing some questions on the Webwork. So, first question, this is problem number 5, or no, this is not problem number 5, this is number 2. Okay, so the question asked to find the equation for the tangent line at point t equals 2 and t equals negative 2. So, this question is pretty simple. We have to know the equation dy over dx. This is the slope. This is equal to dy over dt over dx over dt because so this is because um this is just a very complex version of dy over dx because this dt cancels each other out. So we have dy over dx. So it's just a more expanded version of this. So this is also dy over dt is the derivative of y in respect to t. So we can just say that this is y prime of t over x prime of t. Now everything here is simple. Um, we know that we first have to take the derivative of this x. So x is equal to, and then we take the derivative of t cubed minus 4t. So x prime of t is equal to 3t cubed minus 4. And we do the same for y. We get 8t minus 4t cubed. Now we uh, substitute it into this equation. So 8t minus 4t cubed over 3t squared minus 4. So we would write that here. 8t minus 4t cubed over 3t squared minus 4. Now, it says for t equals 2, so we have to find the slope at point t equals 2, which is pretty simple. We just substitute 2 into every t here, and that would get us to um, 8 times 2 is 16. Plug in 2 and t, we get 8, 32, minus 2, 6, minus 4. So we would, oh no, 2 squared, 4 times 3, 12, minus 4, and we'll get 8. So this is just negative 2. Alright, that is our slope. They want it into the form of y equals mx plus b. We know that m is negative 2. We put x in the front. And then we would have to put, we have to find the B intercept. But in order to find the B intercept, we just plug in 2 into every value of x and y. So let's do that. So x of 2. We plug the 2 into the original equation. And then this is 8 minus 8, which is just 0. Y2 is equal to, and then this would get us 16 minus 16, which is 0. So, um, if you do this into the, if you put this into the intercept format, you would get y minus 0 is equal to negative 2x plus, wait, oops, negative 2x minus 0. So they're both zeros, so it doesn't matter. So we just get y equals negative 2x. So that is the answer to this one. They want you to do the same thing, but for t equals negative 2. So just use what I did here in order to figure out the answer to the second one. All right. So next question we'll be doing is we will be doing the second derivative. Okay, so let's take that out. this is question number 4 on the Webwork. Uh, so find dy over dx expressed as a function that they want you to find the derivative and the second derivative and the concavity. Okay, so for this question, it might take a long time, the second derivative, because there's just a lot of trig functions here. So let's find dy over dx. Again, we use the format dy over dx is equal to y prime of t over x prime of t. And then now we have to take the derivative of y in respect to t. So y prime of t is equal to, um, and then we'll have to use chain rule for this. So 3, and then you would get 6 sine of t times the derivative of the inside, which is cosine of, let me write that neatly, cosine of t. Okay, now we have to find the derivative of x, and we would get 3 cosine squared of t times the derivative of the inside. Those just become negative, and then sine of t. And we put y over x, so we're pretty much putting this whole thing under this, and then if you do that, this sine will cancel out, this cosine will cancel out, and then this will just be 1 cosine. This will also cancel out, and we would get negative 2 over cosine of t. Okay, that is the second derivative. That's the first derivative. Now let's do the second derivative. Okay, all right. Let me put the picture again back up here. The second derivative is kind of different. Um, so d squared over dx squared, and you have to memorize this. This is equal to d over dt times dy over dx over dx over dt. And as you could see, if you guys like actually do algebra and cross things out, this would equal to the second derivative. Okay, so this dy over dt, this part right here, is what we got on the last answer, negative 2 over cosine of t. So we're pretty much taking the derivative of negative 2 over cosine of t. And then this is all divided by the derivative of dx over dt. And we found out that the derivative of dx over dt in the last problem was 3 cosine squared, negative 3 cosine squared sine, okay, it's supposed to be t, sine t. This is what we find out for the last last problem. And then now we have to take the derivative of negative 2 over cosine of t. Well, this is pretty easy because this is just negative 2 d over dt of secant, because 1 over cosine of t is secant, right? So derivative of secant of t, and then all over this thing, right? And when we take the derivative of secant of t, we would get secant of t times tangent of t. And then this is obviously multiplied by negative 2 here. This is all over negative 3 cosine squared of t sine of t. And that would be your answer for the second problem. Good luck typing that in into the Webwork. I mean, we can simplify it, obviously. And we could definitely simplify this. We know that a secant is 1 over cosine, so this would become cosine cubed in the denominator. Tangent is just sine over cosine. So it'll just like the sine will kind of cancel out, and then yeah, this could be a lot simplified, but Webwork takes this answer, so